Hello student, now we are going to see some examples based on equivalence relation. The example is given here.
Hello students, dear students, now we are going to learn the concept of even and odd permutations. A permutation sigma belongs to Sn is called even if its sign is +1 and it is called odd if its sign is -1. For example, consider a permutation. Consider a permutation sigma is equal to (1, 2, 3) belongs to S3. Then this permutation is a even permutation because what is sign of sigma? Then sign of sigma or signature of sigma is equal to sigma of 1 minus sigma of 2 divided by 1 minus 2. This is a continuous product of all such symbols into sigma of 1 minus sigma of 3 divided by 1 minus 3 into sigma of 2 minus sigma of 2 minus sigma of 3 divided by 2 minus 3. This is equal to sigma of 1 is 2, sigma of 2 is 3. This is 2 minus 3 divided by 1 minus 2 into sigma of 1 is again 2, sigma of 3 is 1, 2 minus 1 divided by 1 minus 3 into sigma of 2 is 3 minus sigma of 3 is 1, 3 minus 1 divided by 2 minus 3. So this 2 minus 3 get cancels with this 2 minus 3. This 1 minus 2 get cancels with this 2 minus 1 with minus sign, and this 1 minus 3 get cancels with this 3 minus 1 with negative sign. So this is equal to +1. Therefore sigma is even permutation. Sigma is even permutation. What can you think about the identity permutation? Is identity permutation is an even permutation? Is identity permutation is an even permutation? So let us take the second example that. Let us consider the identity permutation. Identity permutation is equal to, this is 1, 2, 3. 1 goes to 1, 2 goes to 2 and 3 goes to 3. This is identity permutation belongs to S3. Then signum of this ID or signature of this ID is ID of 1 minus ID of 2 divided by 1 minus 2 into ID of 1 minus ID of 3 divided by 1 minus 3 into ID of 2 minus ID of 3, that is image of the 3 under identity permutation, divided by 2 minus 3. So you can have this ID of 1 is 1, that's 1 minus 2 divided by 1 minus 2 into 1 minus 3 divided by 1 minus 3 into 2 minus 3 divided by 2 minus 3. This is equal to, if you take a bracket, then no doubt, this is equal to 1 here. Each bracket cancels with this. So this is equal to 1. Therefore, identity permutation is always an even permutation. Thus identity permutation is always an even permutation. Number 1, identity permutation. Identity permutation is always even permutation. Then second remark is, what is the sign of transposition? Let sigma equal to AB be a transposition. Then what is the sign of the sigma? Then signature or signum or sign of sigma is equal to sigma A minus sigma B divided by A minus B. Assume that here A is less than B. So this is equal to sigma A is B and sigma B is A. B minus A divided by A minus B. So this is minus 1. Therefore what we have? Therefore transposition is always an odd permutation. Transposition is always an odd permutation. Therefore second remark, transposition is always odd permutation. And the third and fourth remarks are, sign of sigma circle tau is equal to sine of sigma into sine of tau. Fourth one, sine of sigma inverse is equal to sine of sigma. Next, we have to see the proof of this interesting theorem. The statement of the theorem is what? See what this theorem says. The statement of the theorem is, if a permutation sigma belongs to Sn, can be written as a product of R transpositions and also a product of R dash transposition, then either R and R dash are both even or R and R dash are both odd. That is, R and R dash have the same parity. Same parity means what? The two numbers are both even or both odd, but then that numbers are called, the numbers should be same parity. Let us see the simple proof of this theorem. So suppose that a sigma belongs to Sn can be expressed as a product of R transpositions. Suppose a permutation sigma belongs to Sn can be expressed as a product of R transpositions. Say, suppose these transpositions are tau 1, tau 2 and so on to R. Therefore sigma is equal to tau 1, tau 2, tau 3 and so on to R. Therefore sine of sigma is equal to sine of sigma is equal to sine of tau 1 into tau 2, tau 3 and so on tau r. So what is the sine of tau 1, tau 2, tau 3 and tau r? This is equal to, we already have that, sine of sigma circle tau, that is the product of sine is equal to sine of the product. Sine of the product is equal to product of sine. So using that property, we have here this sine of tau 1, tau 2, tau 3, tau r is equal to sine of tau 1 into sine of tau 2 into sine of tau 3 and so on sine of tau r. So this is equal to, what is this? See here, this tau 1 is a transposition, tau 2 is a transposition. So sine of tau 1 is what? Sine of transposition is always minus 1. Sine of tau 2 is always minus 1 because tau 2 is also a transposition. Sine of tau 3 is minus 1 and so on minus 1. This is the product of r minus 1. So this is equal to minus 1 raised to r. This is equal to minus 1 raised to r. Similarly, again suppose that let sigma can be expressed as a product of r dash number of transpositions, r dash number of transpositions. Therefore this sigma can be written as, therefore sigma is equal to, suppose that transpositions, take that transpositions as sigma 1, sigma 2 and so on sigma r dash. So therefore sine of sigma is equal to sine of sigma 1, sigma 2 and so on sigma r dash. What are these sigmas are? Sigma 1, sigma 2 and so on sigma r dash are transpositions, in SN. These are the transpositions in SN. This is equal to, we already know that sine of, this is a product of sigma 1 into sigma 2 into, so this sine of a product is equal to product of sines. So sine of sigma 1 into sine of sigma 2 into and so on into sine of sigma r dash. So what is sine of sigma? Sigma 1 is a transposition, sigma 2 is a transposition. So sine of sigma 1 is minus 1 into minus 1 and so on into minus 1. How many minus 1s are there? This is r dash number of times, So this is equal to minus 1 raised to r dash. See here, this is again a sine of sigma, call this as a 1, and this is sine of sigma, call this as a 2. Okay, then from 1 and 2 what we have? From 1 and 2 we have, on both sides we have sine of sigma, so minus 1 raised to r must be equal to minus 1 raised to r dash. So what can you say about r and r dash then? See here, if r is even, then this minus 1 raised to r is plus 1. And if this r dash is odd, then minus 1 raised to r dash is minus 1. So plus 1 cannot be minus 1. So this implies that both r and r dash are, if r is even, then r dash must be 1. If r dash is odd, then r must be 1. This implies that both r and r dash are even, or both r dash and r are odd. Why this is we have written? Because if r is even, then minus 1 raised to r is plus 1, and if r dash is odd, then minus 1 raised to r dash is minus 1. So we cannot get the equality. So r dash must be a even. If r is odd, then this also must be a odd. Hence the proof. Hope you understand. Thank you, student.